This is the Python script that creates the core and cavity region from the generated product. So if I run the script, you will see this is the product first we create, and from this product the core side and the cavity side is generated. How we are doing that? First I will create a cross-sectional profile. It's a star-shaped cross-sectional profile, and from this it will act as a bevel object for the curve, and this line we will create a taper object. This is a NURBS curve that will act as the taper object. This is the function that we will create curve object, and this will be the control points for the curve that we are going to generate. This is a straight line along z axis with control point at 0, 20, 40 and 60. 4 control points. Then we will assign the previous taper and bevel object, the star one cross sectional profile, and the taper object as an NURBS path. Then we will give the taper distance for the outer object, and here we will give the taper distance for inner object. The outer object we will name it as a curve outer, the inner object will name it as curve inner. From the boolean of curve outer with curve inner we will get a product surface, and this is this distance, this thickness we are getting from this value. This is the inner value, tapering inner value, and this is the outer value which is responsible for the outer surface. And we have to convert the generated curve inner and curve outer object to mesh object, otherwise we cannot do the boolean operation. In Blender there are different types of objects: mesh, curve, surface, etc. For the next video I will be focusing on this metaball objects in order to create a conformal cooling channel. So the mesh object, we got the mesh object, then we do the rename the objects curve outer and curve inner based on the region. We will name it as cavity and core. Then we will make two cube. One is for creating the cavity region, other is for creating the core region. From the cube we will use the bisectional plane in order to retain the core side and to retain the cavity side. Then here is the boolean operation. From the retained bisected area we will do the boolean, one with the curve outer, and that will be cavity side, and one with the curve inner, that will be the core side. Then we are making this product by subtracting curve inner from the curve outer object. Then we will assign these keyframes in this line. This is for translation. If we play this is translation. First we will assign keyframe for translation in this section. Then you will see, if I drag this to, you can see the rotation. The rotation will start from 155. So here from this region to this region is rotation. So we are assigning the keyframes here. The next section we will orient this view. First we fit the view, then we will orient the view to the positive y-axis facing the viewer side, and adjusting the camera distance, viewport camera distance. Then we set the frame initially to 0. Then we will run the animation play. We are creating a function called AnyHandler, means animation handler. In order to check whether it is reached the frame rate frame 220, if it reaches frame 220, then it has to stop the animation. Or we can set here, if it is 220, that is the end value. If we can set as c dot frame underscore end instead of 220. But if you can give any value, if it is 180, it will stop when it reaches the 180. What the function is doing is, if it reaches the value, then it will close, then it will call a function called cancel the animation, screen dot animation underscore cancel. It will cancel the animation, but we have to pass this function to bpy app handlers frame change pre dot append. It will continuously check while the animation is running. So that is the essence of this program. You can go through it. If you have any doubts, you can ask. Thank you.